right, in this video lecture, I'm going to talk about neutralizations, which is when you combine an acid and a base, and as a result, you end up with water and salt. So neutralizations, basically you're taking like two very dangerous substances and combining them to form water and a salt. So when your stomach is upset, which means that it has created an overproduction of acid, you can take an antacid tablet, and basically that is a base, and the base and the acid mix, and you produce a salt called magnesium chloride and water. Or if you take a look at this example right here, H3O, which is a hydronium ion, combined with a hydroxide ion, yields water. Now there's no salt produced here. You just end up with two molecules of water, and hopefully you can see that, where this H gets transferred to here. So now I'm just left with H2O because it's lost in H. So this is my acid because it's donating that proton. And this is my base because it's accepting it. And now because it's accepting it, it's HOH, which is just H2O. It's got two H's and one O. So I end up with two molecules of H2O. Or hydrochloric acid plus sodium hydroxide. Okay, so the H combines, like swaps places with the sodium. And now I'm just left with the salt, NaCl, right? And then over here I'm left with HOH, which is water. Okay, so that's how neutralizations work. We're basically, well, in this case, we're not swapping, we're just transferring, and then you get left with two water molecules. But in this case down here, we are swapping. That double displacement reaction, the H is swapping places with the Na. So now I end up with a salt, NaCl, sodium chloride, and HOH, which is water. Okay, so we're going to do a couple of examples. Complete the equation, label the acid, base, and the salt. So I have H2SO4. This is my acid. Acids usually start with an H in the front. And then I have calcium hydroxide. And because I see the OH, that's a base. Okay? So when we do this, okay, we are going to swap places and form our salt. Now, a lot of these are polyatomic, now that I'm seeing this, because we are making a salt, and salt is an ionic compound. We have to make sure that the charges are balanced. So here was an easy swap. Sodium on the periodic table is in group 1 as an overall, usually a +1 charge, and chlorine, which is weighted over by group 17, has a -1. It's a halogen, so this +1 and -1, the charges are balanced. Okay, so just keep that in mind. So SO4, of course I don't have my chemistry book, and here I am recording at 3:30 in the morning. Better look up a list of polyatomic ions. Okay, so I have SO4, -2. I'm just going to leave that there. Okay, so we are going to swap places, okay? So I end up with my positive ion, calcium. If I look at the periodic table, that is an alkaline earth metal, group 2, +2 charge. And SO4 was polyatomic, and it had a -2 charge. Okay, so CaSO4. This works. +2, -2, charge is balanced. But then I also end up with, I'm moving this H2 over. Okay, so I have this H2, so 2 hydrogens, plus 2 hydroxides. Right, that little 2 goes to everything inside the parentheses. So basically, I'm really going into depth here. I have 2 OHs okay? And I'm going to give an H here and an H there. So I'm going to end up with HOH, which is water. But not just one, two water molecules. 2 H2O. Nice. Okay, HBr plus LiOH. All right. Oh, no, we are not done. Sorry. We need to label our acid, base, and our salt. So, because H2SO4 donated, had the H in front, the proton, this is my acid. Calcium hydroxide is my base. And it's mostly because I see this OH here. And your salt is always going to be on the product side. So which one of these two is my salt? Oh, that would be your calcium sulfate. Now I'm done. Okay, back to this example. HBr plus LiOH. So I have a hydrogen in front. This is going to be my acid. I see the OH. That is going to be your base. We are going to do a double displacement here. So my salt, I put my positive cation first, Li. If I look at the periodic table, it's a +1 charge. Br, bromine, is a halogen, group 17. Looking at the periodic table, it's a -1. Whew, that's easy. LiBr, +1 -1 cancels out. Lithium bromide. Plus HOH. So HOH is really H2O. So lithium bromide is my salt. All right, potassium hydroxide plus nitric acid. So which one of these is my base? This one. Because you can see the hydroxide. This is my acid. It has a hydrogen in the front. Usually acids have a hydrogen in the front. Okay, so the H is going to swap places with the K. All right, so H swap places. So I have an HOH, that is water. And then my salt is going to be KNO3. Now, let's make sure that our charges are okay. Potassium, okay, group 1 element, +1 charge. NO3, what, do you know it off the top of your head? If you do, awesome. Here's NO3 nitrate, -1 charge. So charge is balanced, +1, -1. So this is my salt. Write the formula expression for a neutralization reaction that form each of the following salts. Okay, so here I'm given the salt. Okay, so remember with our equation, our general equation, we have this acid plus a base produces the salt plus the water, right? And we have been talking about how do we identify an acid? Well, it's anything that has usually a proton in the front, an H. And how do we identify a base? Usually has OH in it, usually, okay? All right, so this NaCl, I'm going to see if I can move this. All right, so these are my salts, okay? So I'm going to try to figure out what the acid and the base were. Right? Okay, so usually we had the hydrogen swap places with the thing in front of the OH. So what I'm going to do is I'm going to add an OH here, okay, and an OH. Yep. Okay. And that H and that OH is going to form my water. So now all I have to do is split my salt, because one of them is going to go here and the other one's going to go over here. But the question is, which one? Well, hydrogen has what kind of charge? It's +1. So it usually pairs with the anion. So when I take a look at salt, which one has the negative charge? Chlorine. Okay, so the HCl goes here, and the NaOH, or the Na, goes here in front of the OH. So I had a +1 and a -1. Those balance out. And then sodium has a +1 charge, and hydroxide, that's polyatomic, and I would hope you would know by now, but hydroxide is a -1 charge. So we're fine here, +1, -1. So hydrochloric acid plus sodium hydroxide yields sodium chloride plus H2O. All right, take a look at the next one. Why does it say assessments there? I don't know. Okay, magnesium bromide. Okay, so I'm going to set it up. Got OH and H. Okay, from that I get water. Okay, so now the hydrogen has a +1 charge. Okay, so it's going to pair with the anion. Which one of these two is the anion? It's going to be the Br. So I put the Br here. Now, you may have noticed that the Br, there's two of them. So bromine, group 17, is a -1 charge, but now I have two of them for this overall -2. Okay? Magnesium, what's the charge of magnesium? +2. So that's why I only have one. Okay? It's +2. I need two bromines to cancel everything out. So if I have two bromines here, I have to have two bromines here. So I'm going to slap a 2 right here. Because if I added a 2 here, well, now I'd have to have 2 to my hydrogens to balance out that charge. So I'm just going to put a 2 in front of everything there. All right, plus my OH. This is a -1, right? Charge. So I have magnesium, the cation. However, the charges don't balance. Magnesium is a +2 and hydroxide has a -1. So I need 2 hydroxides to balance that out. Okay. Now, just down here, I'm going to make a little note. I have 2 OHs. Okay, and I have 2 H's. So how many water molecules do I need? I need 2 of them. All right. This is a table that's in your homework. It does list some of the acids, not all of them, but you know, it had hydrochloric acid and it had hydrogen bromine. So I don't know, I just included a table just to show you acids usually have an H in the front. And bases, well, they kind of vary. So recap, basically you have an H in front of your acid and it combines with a base that has an OH, and then you get a salt and water. So these are some more examples of salts that are formed. Okay, so I'm going to go ahead and slide it over because it's kind of a pain to write in notebook on the notepad. All right, here we go. So last couple set of problems here. All right, I'm going to end up with water. That water forms from the H in the front and the OH of the base. Now I got to take my salt and split it. Now calcium has a +2 charge. Is calcium going to go with hydrogen, which has a +1 charge, or the hydroxide with a -1 charge? It's going to go with the hydroxide with the -1 charge because we need opposite charges. If you stick a positive with a positive, it's not going to bond. So I stick calcium here. However, calcium is a +2 charge, and the charge of OH is -1. So how many OHs am I going to need? I'm going to need 2. So I have calcium hydroxide. Okay, and then I have my NO3, which is nitrate. It's polyatomic, NO3, nitrate. That's going to go here. Now I have 2 of them because there's this, it has a -1 charge, but I had 2 of them to have this overall -2 charge. So I have 2 of them. Well, if I have 2 NO3s, I would need 2 hydrogens. I'm just going to stick a 2 here. Okay, now I have 2 OHs. So if I were to write OH here, an OH on top. And in neutralizations, it combines with hydrogen here. How many water molecules am I going to have? I'm going to have 2. So I'm going to come back over and put a 2 here. There. 2HNO3 plus CaOH2 produces CaNO3 2 plus 2H2O. Okay, the next one. So I got my NaO3. Here's my base, my OH. Here's my acid with the H, and it produces water. All right, so now it's time to split the salt. So hydrogen has a +1 charge. Is it going to bond with the sodium that has a +1, or the NO3, which has a -1? It's going to bond with the NO3 with the -1. So my cation, sodium, that has a +1, is going to bind with the hydroxide that has a -1. There, that one was easy. Okay, last one here, copper sulfate. Okay, copper has a +2 charge in this case because the sulfate, SO4, is polyatomic. And if I look at SO4, it has a -2 charge. So in order to balance that -2 charge, copper has to be a +2 charge. Okay. All right, so in a neutralization reaction, I'm going to form water. And that water forms from the OH of the base and the hydrogen in front of the acid. Okay, so split the salt. Which one's going where? Well, hydrogen has a +1 charge, so it's going to bond with an anion, so it's going to be SO4. However, do these balance? If SO4 has a -2 charge and hydrogen has a +1, they do not. So that means I need 2 hydrogens, okay, to get to a +2, so it cancels out the -2 of SO4. And then my cation, copper, is going to bind with my hydroxide. What's the charge of copper? It's a +2 charge. What's the charge of OH? -1. So I need 2 of these. Because this is a -1, and now this is an overall -2 with an overall +2. And they cancel. Am I balanced? Well, I have 2 OHs here. And there's the hydrogen, so there's one here. And the other hydrogen will go down here. So how many water molecules do I have? I have 2. All right, so that does it for neutralizations.